In this episode, we move into a newer security topic that still fits the same core logic you have already started building as a beginner. Artificial intelligence, AI, systems are showing up in search tools, customer support, content filtering, analytics, assistance, and decision support across many organizations, which means security learners now need a basic way to think about how these systems can fail. One of the most important risks to understand is model poisoning, because it can quietly damage the trustworthiness of an AI system long before anyone realizes something is wrong. This matters for beginners because the problem is not just technical sabotage in some distant research lab. It connects directly to familiar security goals like protecting integrity, protecting privacy, and protecting availability so that an organization can trust what its systems are doing and keep using them safely when they matter most. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A good starting point is to understand what an AI model is at a very simple level. Traditional software often follows clear instructions written for specific tasks, but many AI systems learn patterns from examples, data, feedback, or prior training so they can generate outputs, recognize patterns, or support decisions in ways that feel more flexible. That flexibility is useful, but it also means the quality of the model depends heavily on what it learned from and how its behavior is maintained over time. A beginner should think of an AI model a bit like a student that absorbs lessons from many sources and then starts answering questions based on those lessons. If the lessons are solid, the student may perform well, but if the lessons are biased, corrupted, misleading, or quietly manipulated, the student may still sound confident while giving poor or harmful answers that are much harder to spot than a simple broken program. Integrity is the first protection goal that becomes especially important here, because AI only helps an organization when its behavior remains trustworthy enough to support the purpose it was meant to serve. In ordinary security language, integrity is about protecting data, systems, and processes from improper or unauthorized change so they remain accurate and dependable. In an AI context, that idea expands a little because it is not only about whether a file was altered. It is also about whether the model's learned behavior has been influenced in a way that makes its outputs less reliable, less fair, less accurate, or more dangerous than they should be. If a model that once identified harmful content begins missing obvious cases, or a model that once summarized information cleanly begins producing distorted recommendations, integrity may have been weakened even if the system still appears to be running normally on the surface. That is why integrity in AI is closely tied to trust in the model's behavior, not just trust in the server that happens to host it. Model poisoning is one of the main ways that integrity can be damaged. At a basic level, model poisoning means an attacker or careless contributor influences the data, feedback, or update process in a way that causes the model to learn the wrong lessons or produce the wrong behavior later. Instead of attacking the finished system directly at the final moment of use, poisoning tries to shape the model earlier, so the damage is built into what the model believes, favors, ignores, or misclassifies. This can be especially dangerous because the system may continue looking healthy to casual observers while carrying a hidden weakness underneath. A poison model might perform badly only in certain cases, favor certain harmful patterns, fail open when it should be cautious, or begin producing outputs that serve someone else's agenda. For beginners, the key point is that poisoning is not always about making a system crash. It is often about making a system quietly wrong in a way that undermines trust over time. There are several high-level ways poisoning can happen, and none of them require you to imagine a science fiction scenario. If an organization trains or updates a model using data gathered from outside sources, user submissions, public collections, or third-party providers, bad information may be mixed in without proper review. If feedback loops are used to improve the system, attackers may try to flood those loops with misleading signals so the model learns the wrong pattern. If internal contributors can modify training sources or labels carelessly, accidental poisoning can happen even without malicious intent. A vendor could also pass along weak or compromised data that becomes part of the organization's model lifecycle. The lesson for a beginner is that AI risk often enters through normal business processes such as collection, labeling, updating, or integrating, which means security thinking must pay attention to how the model is fed and maintained, not just how it behaves at the final user screen. One reason model poisoning deserves serious attention is that the damage can be subtle rather than dramatic. A poisoned model may still answer many ordinary prompts well, still pass simple tests, and still appear useful enough that people keep trusting it. The trouble appears when certain edge cases, targeted situations, or sensitive decisions begin to reveal bias, unsafe output, missed threats, or manipulated recommendations. Imagine a security monitoring tool that starts ignoring a narrow pattern of suspicious behavior, or a fraud system that becomes oddly lenient towards specific transactions, or an AI assistant that consistently steers users toward unreliable conclusions on one topic. These failures may not look like a classic outage, so they are easy to overlook at first. That is why poisoning is not just a data quality problem. It is a trust problem, because the organization may continue relying on the model while its judgment has already been bent away from the mission it was supposed to support. Privacy connects to this topic in more than one way, and beginners should resist the temptation to treat privacy as a side issue. A model can create privacy concerns if the data used to train, update, or improve it contains personal information that was gathered too broadly, handled carelessly, or used beyond its intended purpose. A poisoning event can make this worse because weak data governance often creates the same messy conditions that allow both manipulation and privacy failure. If an organization does not clearly control what information enters the model pipeline, who can handle it, and why it belongs there, then personal data may be exposed to unnecessary processing or mixed into places where it should never have been used. Poorly governed AI can also encourage people to submit sensitive information into tools without understanding how that information may influence future outputs or be retained in surrounding systems. For beginners, the larger lesson is that privacy depends on disciplined data handling, and disciplined data handling also helps reduce the chance that poisoned or low-quality data will shape the model in harmful ways. Availability may seem less obvious at first, but it matters just as much because an AI system that cannot be trusted may become an AI system that cannot be safely used. If poisoning causes output quality to drop, alerts to become unreliable, recommendations to become risky, or content moderation to become inconsistent, an organization may have to pause, retrain, restrict, or even shut down parts of the service while investigating. That means the system may still be technically online, but functionally unavailable for its intended purpose. Availability is not just about whether a server responds to a request. It is also about whether authorized users can depend on the service when needed without unacceptable risk. If a model has been poisoned badly enough, the organization may lose time, operational confidence, and decision support precisely when it needs them most. This helps beginners see that integrity, privacy, and availability are connected, because a serious blow to one of them often creates pressure on the others as well. There are several misconceptions that can make new learners underestimate this risk. One is the idea that only large technology companies need to worry about model poisoning, when in reality, any organization using AI for filtering, scoring, ranking, prediction, support, or workflow assistance can be affected by bad training inputs or bad update practices. Another misconception is that poisoning must come from a brilliant external attacker working in secret, when ordinary weak governance, careless data collection, poor labeling, or unreviewed vendor inputs can create similar damage. A third misconception is that an AI system is safe as long as it sounds polished or usually performs well. Confidence in tone is not the same as confidence in integrity. A beginner should learn early that AI can appear helpful while still carrying hidden weaknesses, and that security depends on disciplined oversight rather than on being impressed by how smooth the system seems during normal use. A practical beginner mindset starts with simple questions about the model's learning environment rather than with technical fascination about the model itself. Where is the data coming from? Who is allowed to contribute to it? Who reviews it? How are changes approved? And what signals would suggest that output quality has shifted in a concerning way? Those questions matter because poisoning often succeeds when the path into the model is easier to influence than the organization realizes. If too many people can shape training data, if no one checks the quality of feedback, or if updates happen without traceable review, the model becomes easier to bend in the wrong direction. Just as important, organizations need a baseline sense of what normal behavior looks like so unusual changes can be noticed sooner. Beginners do not need to memorize advanced defenses to understand this point. Security improves when inputs, changes, and outcomes are treated as things that deserve scrutiny rather than blind trust. At a high level, protecting AI against poisoning requires many of the same habits that protect other important systems. Organizations need clear rules for data sourcing, review, approval, retention, and removal, so the model is not learning from a chaotic stream of material with no real ownership. Access to model updates, data labeling, and training inputs should be controlled according to role and responsibility rather than convenience. Important changes should be traceable so the organization can see what was changed, when it was changed, and by whom. Third-party data and model components should not be treated as automatically trustworthy just because they are external or widely used. For a beginner, this is an encouraging lesson because it shows that AI security is not magic. It still depends on familiar governance ideas such as accountability, separation of duties, careful review, and respect for how bad inputs can shape future outcomes. Human oversight remains essential because AI does not defend its own trustworthiness in the way people sometimes assume. Even if a model is advanced, it still depends on people to define acceptable behavior, monitor output quality, question odd patterns, and decide when something should be slowed down or rolled back. A healthy culture encourages staff to challenge suspicious output instead of treating every response from an AI system as authoritative. This matters especially when the tool supports security, hiring, customer response, compliance review, or other decisions that can affect people or operations in meaningful ways. When humans become too passive around AI, poison behavior can hide for longer because no one wants to be the person who questions the smart system. Beginners should learn early that responsible use of AI includes the courage to doubt it, review it, and limit it when trust has not been earned or when behavior starts drifting away from the mission it was meant to support. This topic also connects well to exam-style decision-making because questions often reward sound judgment over dramatic technical action. If you are presented with a scenario involving unreliable AI output, suspicious learning inputs, or unexplained changes in behavior, the strongest answer will usually emphasize validating sources, limiting unauthorized influence, reviewing updates, protecting sensitive data, and preserving safe operation rather than assuming the model should simply be trusted because it is already in use. A beginner should train the mind to look for the root issue underneath the AI label. Is the real problem weak integrity because the model learned from corrupted inputs? Is privacy being threatened because sensitive information is being collected or processed without proper control? Is availability being weakened because the organization can no longer rely on the system's output enough to keep using it confidently? Once you identify which protection goal is under pressure, better security reasoning becomes much easier even if the scenario uses newer AI language. As we close, remember that model poisoning is not a distant specialist topic that only matters to researchers. It is a practical trust problem that affects whether an organization can believe its AI system, protect the people whose data may touch that system, and keep using it safely when it matters. Integrity matters because the model must remain dependable rather than quietly learning harmful behavior. Privacy matters because data feeding the model must be collected, used, and protected with discipline and restraint. Availability matters because a model that becomes untrustworthy may become unusable, forcing interruption at the exact moment support is needed. For a beginner, that is the most useful way to carry this topic forward. Do not focus only on the novelty of AI. Focus on the familiar security question underneath it, which is whether the system can be trusted to operate in a way that is accurate enough, respectful enough, and dependable enough to serve the mission without introducing hidden harm.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.